Okay, there's one last thing I want to talk about with intensity, which is pretty interesting. So I'm going to make a linear, or actually more than linear chirp. I'm going to make an exponential chirp so that goes up linearly in pitch. So I'll make this 110 times 2 raised to, I'll go through 7 octaves over 5 seconds. Okay. And I want you to listen. So notice, I mean, the amplitude is not changing here. I made the amplitude 0.1. But I want you to listen carefully to what you perceive the intensity to be. Okay? So again, it should not be changing intensity if I don't think intensity changes for a fixed amplitude. Okay, so let's see. So what you should hear is the intensity starts off low and then starts to sound really intense and then kind of backs off a little bit. So what's really interesting is for the same power, so for the same loudness, physical loudness, so constant physical loudness, we actually perceive different intensity at different frequency ranges. So it's not just the decibel system that's at play here. There's another thing going on in the background that affects this. So I want to actually plot, okay, so here's this curve in amplitude. So this curve represents equal loudness. The amplitudes that you would need to make your sinusoids have the same perceived loudness. So I can see that, again, you know, at the beginning, I can have a rather large amplitude. But to get the same loudness, I really need to scale the higher frequencies down. They get pretty loud. Okay, so I need to scale those down. So this is what the amplitude should be. Let me express this in decibels as well. So instead of amplitudes, I'll say dBs equals 10 mp dot log 10 amplitudes squared. So this is decibels. This is how you would normally see it expressed. So yeah, we see, you know, up to about 1,000 hertz, which is just above the first octave of concert A. You know, pretty low at the low. You know, we have to have a pretty high amplitude at the low frequencies to hear it. And then, but you know, not too much change in loudness up here. But suddenly it gets really loud once we go past the second octave beyond concert A. So we gotta actually put it down to a lower decibel level to hear the same thing. Okay. So I'm just going to have you do a quick exercise where you make the amplitudes be this amount for a chirp, and you're going to hear that instead of sounding like it starts off low, gets loud or intense, and then bounces back, it should sound the same the whole way through. And that's the last exercise in this module.